Hello and welcome everyone to BBS Global Day. This is a historic day. This is the largest gathering of people affected by BBS in history. We have more than 300 people registered from more than 30 countries around the world and are going to be covering some really interesting and important information. But we're going to kick it off with a welcome.
Hi, we're the Moore family.
And we are from Ireland.
And we are proud members of the BBS Global Community.
Hi, my name is Max Netzer. I'm originally from France. I work at UCSF and I study the BBSome, and I'm happy to be part of the Global Beales Syndrome Day.
Wir sind der Mattis und Martina aus der Schweiz.
Und wir sind Teil von der globalen BBS-Familie.
Hi, my name is Erica Davis, and this is my research team at Lurie Children's Hospital of Chicago, where we study rare genetic conditions in children, including Bardet-Biedl syndrome. We are happy to be part of the global BBS community.
Hey y'all, my name's Catherine from Oklahoma and I'm part of the BBS Global family.
Hola, soy la doctora Diana Valverde. Estoy en el CIMBio, en la Universidad de Vigo, en España, y nuestro equipo está dedicado al estudio de los tibios y del síndrome de Bardet-Biedl. Estamos orgullosos de pertenecer a la comunidad global del síndrome de Bardet-Biedl.
Hi, I'm Tim West, and this is Tyler West from Atlanta, Georgia, and we're part of the BBS community.
हेलो मेरा नाम कमाल खान है और मेरा ताल्लुक पाकिस्तान से है। मुझे बेहद खुशी है कि मैं आलमी BBS बिरादरी का हिस्सा हूँ।
Vi er Steffen og Maja fra Danmark. Vi er en del af den globale BBS-familie.
Hi, I'm Pleasantine Mill. I'm Canadian but live in the UK. I'm interested in cilia and ciliopathies and the diversity of how they all come together under one umbrella, and I'm very glad to be part of the global BBS community.
Ich heiße Bernarda Gillissen, komme aus Viersen in Deutschland und bin Teil der globalen BBS-Community.
Hi, I'm David Meeker, CEO of Rhythm Pharmaceuticals, and we are happy to be part of the BBS family.
Hola, soy Mayra.
Hola, soy Amber y somos de Puerto Rico.
Y también formamos parte de la comunidad global del síndrome Bardet-Biedl.
Привіт, мене звати Марія, я з України. Дуже рада бути частиною глобальної спільноти Bardet-Biedl синдрому.
Hej, mit navn er Iris, og jeg er medlem af den internationale globale Bardet-Biedl.
Hi guys, we're Wilkie's Warriors from Scotland. We're delighted to be part of the BBS Global Community.
Wilkie's Warriors!
Alors, je m'appelle Natasha Rivo. Je viens de Ontario au Canada. Je suis partie de la communauté BBS.
Hi, I'm Tamara Caspery. I'm from Atlanta, Georgia. I study primary cilia and the role of ciliary signaling during development, and I'm happy to be part of the BBS global community.
Ich heiße Andrea Kire, komme aus Geldern in Deutschland und bin Teil der globalen BBS-Community.
I'm Dr. Martina Huranova from the Institute of Molecular Genetics in Prague in Czech Republic, where we study cilia and Bardet-Biedl syndrome, and we are happy to be part of the global BBS community.
Siamo la famiglia Montagnoli.
Dall'Italia e facciamo parte della comunità BBS globale.
Ciao a tutti!
Ciao! Ciao!
Hi, I'm Heidi. I work at the Trans Zuckerberg Initiative, where we support patient-led rare disease organizations. We are incredibly proud to be a part of the Bardet-Biedl syndrome community.
Mein Name ist Matthias Kim. Ich komme aus Kassel, Deutschland und bin Teil der globalen BBS-Community.
زمانم شیراز خنده از زاد پاکستان سواد اوسیدون کردم از زاد بخار میرسوم که زاد باردبیدل سندروم در نریوال طولانی حسه.
Hi, I'm Ruth Dameron. My daughter is 41 years old. She has BBS, and when she was 13, we became part of the BBS community.
We are the Fitzgerald family from Alberta, Canada, and we are
part of the BBS Global Community.
Big smile.
So hopefully, as you saw there, this really is a global community. There are families and researchers from all over the world, from all languages, that are part of our global family. I'm Tim Ogden. I'm the president of the BBS Foundation in the United States. And we have an amazing group of folks here today joining us. As I mentioned, more than 30 countries represented. And I want to tell you a little bit about how some things work. First, I know many of you do not speak English as a first language. You can get translated captions by clicking on the captions button at the bottom of the screen and choosing what language you would like to see captions appear in. Also, we have a small bit of time and a lot of things to go over. So we're not going to be doing questions and answers during the session, but you can always feel free to put questions in the chat or to send it to us along the way via email. All of you who registered should have gotten my email address as part of your registration. But I want to tell you who else is here, because this isn't a function of BBS Foundation US. This is a global collaboration. So I'm going to ask our BBS leaders from around the world to turn on their video so that everyone can see who those people are and where they're from. So first, let me introduce Tanya Heimers.
Hi everyone, I'm Tanya Heimers, the BBS patient group leader from the UK, and I'm a parent to 2 adult sons, one of whom has Bardet-Biedl syndrome. So my family has had the privilege of being part of the BBS community for 29 years, and we've really valued the support, friendship and the shared experiences over the years. At BBS UK, we support over 700 people with a BBS diagnosis and more than 1,500 altogether, including families, carers and professionals. We run an advice service, an NHS-funded clinic support service, and we host a wide range of resources on our website. Our team of 9 part-time staff, supported by a board of trustees, most of whom have lived experience of BBS, something that's really important to us and is central to how we work. We're incredibly proud to be working alongside all of you and to be part of this first Global BBS Day webinar.
Ben.
Hi there, I'm Ben Bendert uit Nederland. I'll do it in English because I see the transcription is not so good for the Dutch. I run the foundation in the Netherlands now for 10 years. My son has BBS and he's doing very well. And in the Netherlands, we're very busy now with getting the registry up and running and getting the foundation more and more known with people to come and work with us, trying to better the BBS situation in the Netherlands. So I'm super excited about this global meeting and working with Tim and Tanya. So I'm looking forward to it.
And Iris.
Hej, mit navn er Iris. Jeg er formand i Danmark. I'm the leader in Denmark. We have Neo, he's 9 years old with Bardet-Biedl. We were founded in 2017 and we have about 60 members. We meet with our members 3 times a year. We have a family day and we do the general assembly day. And then we also have a day with adults who has Bardet-Biedl. And it's always a great success to meet with them. We have our own website. It's called bardet-biedl.dk. But we also have our own closed Facebook website, a Facebook group, where us parents can ask each other questions and get help, everything regarding what happens here in Denmark. I would like to also thank BBS International for doing this great job. Thank you.
Thank you, Iris. Matthias.
Ja, hallo aus Deutschland. Mein Name ist Matthias Kim. Ich bin Vater von einem 6,5-jährigen Sohn mit BBS und bin im Arbeitskreis von BBS unter dem Mantel von ProRetina e.V. tätig. Dort haben wir in Deutschland momentan ca. 150 Familien, mit denen wir in Kontakt sind. Und wenn ihr noch nicht bei uns Mitglied seid und mit uns in Kontakt treten möchtet, mit unseren Familien in Deutschland oder im deutschsprachigen Raum, könnt ihr das tun unter der E-Mail-Adresse bbs@pro-retina.de oder unter der Website von www.pro-retina.de unter dem Suchbegriff Arbeitskreis BBS. Und wir sind glücklich, ja, heute hier zu sein. Ich weiß, dass wir einige aus Deutschland hier haben und freuen uns, Teil der globalen BBS-Community zu sein.
Matisse.
Oh, buongiorno, buondì, guten Tag. Mein Name ist Matthias Hungerbühler und ich bin Präsident von der Patientenorganisation Bardet-Biedl-Syndrom Schweiz. Nach der BBS-Diagnose unserer beiden Söhne haben wir uns entschieden, diesen Verein mit meiner Partnerin Martina Huranova zu gründen. Aktuell sind wir im Austausch mit rund 10 Patienten und nach wie vor mit Aufbautätigkeiten betraut, da wir die Organisation vor rund einem Jahr gegründet haben. Also, wenn ihr mitwirken wollt, besucht unsere Webseite bardet-biedl.ch oder sendet uns ein E-Mail an info@bardet-biedl.ch.
Thank you, Matisse. And I'm going to turn the discussion over to Dr. Erica Davis and Dr. Jeremy Pomeroy. Dr. Erica Davis is a researcher at Lurie Children's Hospital of Chicago, is special to me for a couple of reasons. One, she started working on BBS right around the same time my son Nathaniel was born, working on the BBS 10 gene. And I should also note, so special to me that I married her. So we had just had our second anniversary about a month ago. And Dr. Jeremy Pomeroy is the leader of CRIBS, the clinical registry investigating Bardet-Biedl syndrome. So let me hand it over to them for a quick discussion about how much progress we've made in learning about BBS, genetics, and cilia, and the basic science over the last 30 years.
Well, hello, everybody. It's a great pleasure to be here. I've been part of the global BBS family for a very long time and am happy to continue to interact, and also happy to see so many people connected here in one place at one time, including people from my research lab and my clinical colleagues who I know I see in the attendee list. So welcome, everybody. And it remains, even after a few decades of studying BBS, something we still continue to learn about. And this goes everything from how to improve diagnosis. So how can we get people an accurate diagnosis earlier based on their clinical features? So there's a team of clinicians and scientists currently working on this to improve and refine how we can give guidelines to doctors around the world to get people with BBS a diagnosis, or people who think they might have BBS a diagnosis. So that's one important thing. One other important thing is we're working to improve genetic testing in the clinic to try and make sure people can get a test and have it interpreted in the right way. So along with the clinical diagnostic part, there are teams of people coming together to try to find ways to improve how we can get the appropriate counseling to people that they need. And part of this is the establishment of centers of excellence. And I'm very excited to say that we have one that is new at Lurie Children's of Chicago to try and get people multidisciplinary care and to follow them from childhood to adult. And now in the basic sciences, this is where my heart is. There is still a lot of work being done using our research models that range anything from cells to fish to mice to try to understand how everything works. How do the BBS proteins work, and how do they work in the different parts of the body? And I think we've made some really exciting progress moving forward with the hopes of being able to tailor therapies for people. So I don't want to talk about that. I know we have other speakers who will talk about therapies. And I want to go ahead and pass it over to Dr. Pomeroy to tell you about the CRIBS registry.
Thank you, Erica. Hi, everyone. Happy BBS Global Day. I'm Jeremy Pomeroy. I'm a research scientist at the BBS Center of Excellence at Marshfield Clinic, and I want to talk a little bit about CRIBS, which is what I'm responsible for. So CRIBS was established in 2014 as a collaboration between MCRI, the Marshfield Clinic Research Institute, and the BBS Foundation. In June of 2024, we celebrated our 10th anniversary of our first annual interview. CRIBS is open to anyone with BBS. It does not matter what country you reside in or are from. At the heart of CRIBS are annual interviews. We try to speak with everyone in CRIBS every year to ask questions about health and the lived experience of having BBS. And the goal of that is to accelerate research to benefit health and well-being of people with BBS. So in the now 11 years of existence of CRIBS, we have a little over 1,000 people registered from 42 countries. Close to 800 have completed the initial interview. There's been over 3,000 total interviews completed to date, and a little bit over 515 people have shared genetic reports. CRIBS has contributed to research in a couple different ways. Some we use the data from CRIBS to try to answer questions of relevance to people with BBS, and we've done some work looking at the development of things like overweight and obesity and kidney failure and kidney transplants. We also contribute by helping to identify and recruit people to participate in research studies that may be of interest to them. And so one of the things that I really want to emphasize is that if there is a registry in your country, I encourage you to join it. If there's not, CRIBS is open to everyone. It is also okay to join CRIBS in addition to the registry in your country, but it's not necessary. And in order to begin the process of registering with CRIBS, reach out to us. Our website is bbs-registry.org. So thank you for letting me speak with you today, and I hope you have a great BBS Global Day.
Thank you so much, Jeremy. And we keep emphasizing the global nature of what we're doing. And there are researchers and registries around the world working, and we wanted to give the global community a sense of some things that are happening that aren't always so easy to see, depending on what country you're in. So I'm now going to ask Dr. Diana Valverde from the Universidad de Vigo in Spain to come on and tell us what she's and her group has been doing. She's going to speak in Spanish. I think it is important to people recognize that there are every language in the world represented here in the BBS community. So again, if you are not a Spanish speaker and you want to see translations, there's a button at the bottom of the screen called Captions that you can choose to have captions produced in whatever language that you prefer. Dr. Valverde.
Thank you, Tim. Gracias por permitirme estar aquí hoy y bueno, compartir con vosotros pues todo lo que significa el Día Global de la Comunidad de Bardet-Biedl. Soy Diana Valverde, trabajo desde hace más de 20 años en el síndrome de Bardet-Biedl. Empezamos realizando pues, la caracterización genética de los pacientes. Tenemos recogidos hasta el momento alrededor de unos 100 pacientes en toda la comunidad española y bueno, empezamos pues, lo que fue eso, el estudio y la caracterización de los genes y de las familias. Después, bueno, intentamos siempre hacer los estudios funcionales de las mutaciones que nosotros encontramos. Hemos trabajado con peces cebra como modelo para estudiar estas mutaciones, para analizar su significado y cuál es el daño que producen en los pacientes. Y en la actualidad estamos trabajando con unas líneas celulares especiales que hemos realizado para poder tener unas células que son muy parecidas a las de los pacientes, y en ellos estamos haciendo estudios de proteoma, de transcriptoma, de genómica, Y con todos estos datos nosotros estamos profundizando sobre cuál es el papel de estas proteínas en las células y así poder desarrollar pues, alguna terapia que mejore el estado de los pacientes. En nuestro caso trabajamos con modelos celulares para los genes BBS1 y BBS4. Vamos a ir implementando nuestras investigaciones para otros genes y estamos muy contentos porque estamos analizando pues, una serie de rutas de celulares que están siendo muy interesantes y aportando muchos datos. También quiero comentar que estamos inmersos en un trabajo también muy bonito para hacer una correlación entre el genotipo que vemos en los pacientes y el fenotipo, las características clínicas, para poder determinar pues, cuáles son las características clínicas que se diferencian entre los distintos pacientes de Bardet-Biedl según el gen que tienen mutado. Y este proyecto estamos analizando ya los datos, tenemos pues, alrededor de unos 100 pacientes y hemos conseguido pues, que nos los remitan y que colaboren los médicos de toda España. Quiero también contaros que estamos también colaborando con TIM para crear un grupo del síndrome de Bardet-Biedl de habla hispana, ya que no solo sea en España, sino a nivel mundial, todos aquellos países en los que hablen castellano o español, pues podamos hablar y podamos comentar las cosas relacionadas con el síndrome. Para saber más de todo este proyecto que estamos desarrollando en español, os podéis poner en contacto con la BBS Foundation, con Tim, que él os va a contar cómo estamos montando esta colaboración y esta preparación de documentación para todos aquellos pacientes y médicos que estén interesados en este síndrome. Y nada más, me despido y cualquier cuestión, yo creo que gracias a ti estamos todos en contacto y realmente en los años que llevo trabajando en este síndrome es la primera vez que veo una actividad a un nivel mundial tan grande como este. Gracias, Tim.
Muchas gracias, Diana. It's been a pleasure to connect with Diana and her team. I will say for the global audience, I have a particular heart for our Spanish-speaking community. I was born and grew up in South America, and have been very excited to start partnering with Diana, as she said, to help us create more content in Spanish for the Spanish-speaking Bardet-Biedl community. But it's not just Spain. It's also the Czech Republic. And so I wanted to ask Dr. Martina Huranova from Prague to come and tell us about her research in BBS.
Tak. Dobrý deň všetkým. Ja by som chcela zdieľať svoju prezentáciu. Takže ešte raz ďakujem za pozvanie, abychom mohli mluvit o našem výzkumu tady na tomhle úžasným Mezinárodním dnu Bardet-Biedlova syndromu. Já bych chtěla teda říct, že my jsme z České republiky, jsme z Ústavu molekulární genetiky, kde zkoumáme primární cílie a taky tenhle syndrom. A jak již... Teď tady mi to předskočilo. Jak již bude ukázáno, Bardet-Biedlův syndrom je způsoben mutacemi v 26 genech, momentálně jich známo i více, a je spojen s různýma symptomama. Co je velice zajímavé, že projevy tady těch symptomů jsou různorodé a proto jednotliví pacienti mají různé projevy. Buď jsou to třeba polydaktylie, poruchy ledvin, obezita, poruchy reprodukčních orgánů nebo retinální dystrofie. Ale ta variabilita je taková, přináší nejistotu pro ty dané pacienty a jejich rodiny a nás zajímalo, jestli pokud zmapujeme, jak jednotlivé mutace v genech vedou k daným symptomům, že bychom mohli predikovat na základě ty dané mutace, jak tahle mutace vede k tím daným symptomům. A proto, abychom to mohli udělat, tak jsme potřebovali veliké množství pacientů a na to jsme využili 85 studií, které měly zdokumentované genotypy a fenotypy a více než 800 pacientů dohromady. A vytvořili jsme velkou databázu, která je veřejně dostupná a pokud někdo bude chtít doplnit tuto databázi o svoje pacienty, tak se nám může klidně ozvat a my můžeme vlastně tuhle výstup pak z té databáze znovu kvantifikovat a můžeme ho vlastně napravit a updateovat. A co už tady vidíte, máme tam vlastně skoro všechny mutace, skoro všech BBS genů, které jsou postižené a taky máme zdokumentovaný věk, kdy byla tato nemoc diagnostikovaná, takže máme různé věkové skupiny a taky máme zadokumentovanou penetranci jednotlivých symptomů. Protože to je důležité, abychom mohli statisticky vyhodnotit souvislosti mezi mutacema a mezi symptomama. A co jsme zjistili, je, že penetrance, teda to, jak některé symptomy se objevují u pacientů, koreluje taky s určitýma genama, zatímco ve většině genů třeba ty pacienti mají problémy s očima, mají retinální dystrofii, tak třeba u ledvin to není úplně takhle. Tam se zdá, a dalo by se říct, že to je statisticky signifikantní tady v té velké kohortě na těch 800 pacientech, že u některých genů je pravděpodobnost, že dojde k dysfunkci ledvin nižší. Ale mluvíme tady o statistice a o pravděpodobnosti. Pořád ta variabilita v těch genech přetrvává a proto potřebujeme více pacientů a více dat, abychom mohli tohle opravdu prozkoumat a vyhodnotit a vůbec zjistit, jestli opravdu umíme předpovědět vývoj jednotlivých symptomů. A proto taky v České republice se snažíme najít BBS pacienty. Momentálně máme evidovaných 12 pacientů. Ta spolupráce a získávání těch pacientů je náročná. My jsme velice vděční, že se nám podarilo kontaktovat některý. A chtěli bychom také pro nich, protože inspirace z ostatních krajin je veliká, zavést určitou informační podporu, taky jich zapojit do registru, protože zmapování toho, co mají za genotypy, k čemu vedou, je vlastně důležitý pro další pacienty a posouvá náš výzkum dál. Takže apeluji, pokud máte i publikované studie s pacientama z vašich kohort po celém světě, tak nás neváhejte kontaktovat a já vám pošlu formulář, kde to všechno vyplníte a my můžeme vlastně updateovat naši databázi nadále. Takže moc děkuji za pozornost a držím všem palce ve svém životě a přeji všem velkou sílu a děkuji za pozvání a šťastný Mezinárodní den Bardet-Biedlova syndromu. Děkuji.
Thanks, Martina. I just want to call out one thing here for the rest of our audience too, specifically that Martina and her team did this incredible work to go through decades of papers, finding every paper that had data about a BBS patient, no matter where they were in the world, to create this BBS database of almost 1,000 patients. And I know how much work that is. It is not easy to go into a bunch of medical papers and extract the data in the way that you want it to be formatted and to gather the data that you need. And she did that all without anybody asking her to. She decided this is important to the BBS community and to the science. So me and my team are going to go out and do that and have created this incredible resource. And it is shaping things like how we adjust the diagnostic criteria to better identify everybody who's affected by BBS, no matter what gene or how severe or mild their symptoms are. So thank you, Martina.
Thank you.
Now I want to turn it over to Dr. Jeremy Reiter. This is another place where I feel just so encouraged about the progress Dr. Reiter is one of the leading cilia biologists in the world. And we are learning so much about the basics. When Nathaniel, my son, was born, who's almost 20, we're still at the very start of, maybe these primary cilia actually do something. And now we've advanced the science so much because of the contributions of Dr. Reiter and some of his colleagues. So, Jeremy, let me hand it over to you.
Thank you, Tim. Thank you for the opportunity to communicate with this great community of Bardet beetle individuals and their families and associates. It's a real privilege to be here this morning. As Tim mentioned, I'm a biologist at the University of California in San Francisco, and I am very interested in how cilia function, and there's a lot of overlap with how Bardet beetle syndrome works and how cilia function. So I'm interested in the fundamental questions of how cell function changes in the presence of Bardet beetle syndrome. And so this is just a slide indicating on the left-hand side a picture using a technique called electron transmission microscopy, what cilia look like in you and me. And on the right is a metaphor for how we think about those cilia. It's a picture of a radio antenna receiving some cues. So we think of these specialized structures that exist on almost all of your cells as being organelles, part of the cell, that's specialized for receiving cues from the outside world, in the case of, for example, the eye or the nose with vision and smelling, but also for cells within the body to communicate with each other. And those are the cells that we're particularly interested in understanding in my lab. So in the past, my group, which is pictured here in its current form right now, is just a picture of all of the scientists and students who are working in my group, as well as some of our collaborators who are helping us to think about Bardet beetle syndrome, as well as our funding sources. Our group is really interested in the past in understanding some of the ways in which those antennas, those primary cilia, function in embryonic development. And so the origins, for example, of polydactyly in Bardet beetle syndrome, we think might be due to changes in a particular way in which cilia function in development called the hedgehog patterning pathway that helps to dictate how many fingers you're going to form on your limbs. Nowadays, we are also very interested in the function of cilia, not just during embryonic development, but after development as well. And I just want to highlight a student, Gabriela Canales, a PhD student who I'm circling here on the slide, who's standing next to me. And she's the person in my lab who's really been the spearhead of trying to understand the origins of Bardet beetle syndrome, the origins of some of the manifestations of Bardet beetle syndrome, not just during embryonic development, but in adult organisms as well. And because we are a fundamental science laboratory, we use models for Bardet beetle syndrome, and we use mostly modified models of mice in order to recapitulate some of the manifestations of Bardet beetle syndrome and try to understand in mice how a Bardet beetle syndrome gene or protein functions in order to gain more insight into what may be going on with Bardet beetle individuals in our larger community. So just as an example, here I'm showing a picture of a microscopy picture in which we've stained neurons in the brain of mice for these cilia. and they appear as these small rods against a background of these blue circles. These blue circles are the nuclei outside of the cilia. Each one of those represents an individual neuron within the brain. And there are cilia associated with each of those neurons. And in mouse models of Bardet-Biedl syndrome, we can see that those cilia in magenta still exist, but certain proteins, such as this one in yellow, no longer localize to those cilia. So we're starting to understand the fundamental aspects of how those cilia change in Bardet-Biedl syndrome. We also are eager to communicate longer with you, so we write review articles that are meant for a scientific audience, such as this one right here, that talk about how cilia function and how they relate to diseases and syndromes, such as Bardet-Biedl syndrome. So if you are interested, even though this is meant for a scientific audience, there are aspects of this that I think will be accessible to the larger population. And so with that, thank you, Tim, for this opportunity to be able to talk to this community.
Thank you very much, Jeremy, for joining us. This level of, I'm sure so many of you have heard about Bardet-Biedl syndrome and said, how can one thing cause obesity and retinal degeneration and polydactyly and kidney disease and all of the other pieces? And it's the work of people like Dr. Reiter and his lab that are starting to help us understand how it does all of these things. It does something a little different in each type of organ and how all of that works. And to really advance treatment and care, we need to understand why things are going wrong in the eye, which is different from why they're going wrong in the kidney, which is different from why they're going on in the brain, which is different from why they're going wrong in other parts of the body. And so really excited about that research. In our follow-up, we're going to have a full transcript of this, and we'll have links to other resources. I will warn everybody, it took me 45 minutes to understand the first 10 sentences of Jeremy's paper, but you can do it. You just have to put in the time. Thank you very much, Jeremy, for joining us.
Thank you, Tim.
I want to turn it over now to Dr. Mieke van Haelst from the Netherlands, who has been working to expand access to research and care for people with BBS across Europe. Dr. van Haelst?
Thank you very much, Tim. Ik spreek in het Nederlands. Ik hoop dat de vertaling binnenkomt, zodat alle mensen uit Nederland, de patiënten, ouders en wetenschappers mee kunnen luisteren. Allereerst hartelijk dank aan de organisatie voor deze prachtige BBS-dag. In Nederland is het alweer einde van de middag. Ik ben Mieke van Haelst, klinisch geneticus. Ik werk intussen al meer dan 30 jaar in de genetica. En juist de afgelopen jaren zijn enorm fascinerend. Met name omdat er steeds meer mogelijkheden zijn dat er therapie beschikbaar komt voor patiënten die in het verleden alleen gezien werden door de klinisch geneticus met het bericht: dit is de diagnose, dit zijn de herhalingskansen binnen een gezin en dit is de toekomstige perspectieven. Intussen heb ik in Amsterdam, waar ik werk, in Amsterdam in Nederland, een Emma Center for Personalized Medicine neergezet. En daarin proberen wij samen met 32 jonge wetenschappers zeldzame ziekten beter te begrijpen, maar met name snelle diagnostiek en therapie te ontwikkelen. Zodat iedereen die een vraag heeft over een ziektebeeld niet alleen de uitleg kan krijgen, maar ook hoort waar de onderzoeken plaatsvinden en welke therapieën in de tussentijd ontwikkeld worden. In het MSCPM is dat de missie. Maar we hebben ook met name de zorg voor patiënten die in het verleden op verschillende dagen in heel veel verschillende ziekenhuizen gezien werden. Die op dit moment in een one-stop shop gezien worden door alle specialisten samen, ook wetenschappelijke onderzoekers, zodat ze op één moment alle informatie kunnen krijgen en niet de reis naar diverse ziekenhuizen op verschillende dagen hoeven te ondernemen. De patiënt staat centraal en binnen het MRCPM ben ik enorm trots dat wij ook binnen de 32 onderzoekers, Bender de Graaf, die de founder is van de Nederlandse BBS Foundation, dat hij namens de patiënten de leider is van de Patient Participation Team. Dus alle onderzoekers en artsen kunnen bedenken wat de beste zorg en therapie voor de patiënten zou kunnen zijn en welke onderzoeken er verricht moeten worden. Maar het is heel belangrijk om de stem van de patiënt te horen. Zo weten we dat er in Nederland ongeveer 150 patiënten met BBS zijn, maar we weten niet waar ze zijn en wat de vragen zijn, omdat ze verspreid zijn over het hele land. Net als in andere landen hebben we in Amsterdam zijn we gestart met een register neer te zetten. Naar het voorbeeld van de groep van Beales in Londen. Hebben we dat systeem overgenomen waar heel gedetailleerd alle informatie van de orgaansystemen over de oogafwijkingen, de obesitasproblemen, de nierafwijkingen en ontwikkelingsproblemen in kaart worden gebracht. We hopen op deze manier de informatie, maar ook inzicht te krijgen van hoeveel patiënten er in Nederland zijn. Dus we hopen ook alle patiënten met elkaar te connecten. Bender de Graaf heeft ook op deze manier samen met ons een BBS-dag in Amsterdam georganiseerd, waarbij ook alle patiënten hun vragen kunnen stellen en elkaar beter kunnen leren kennen. Wenneke van Weelde, ook aanwezig in deze meeting, is een PhD-student en zij ziet alle patiënten en verzamelt alle gegevens voor in ons Nederlandse register. Het Nederlandse register, het Nederlandse BBS-register, dat ook beschikbaar is voor patiënten uit omringende landen in Europa. Belgische patiënten, Duitse, Franse patiënten, wie dan ook, zijn ook welkom om contact met ons op te nemen en aan dit register bij te dragen. Dat is wat ik vandaag zou willen zeggen. En ik ben enorm blij dat er zoveel mensen deelnemen aan deze prachtige BBS-dag. Dankjewel, Tim.
Thank you, Mieke. Next up, we were supposed to have Dr. Arlene Drack. She's having some technical and home challenges.
Hi, everybody. It's very exciting for me to give a research update for World BBS Day, and I'm really honored to have been asked. I wish I could have been there in person. This is my team of researchers and collaborators. I don't have to tell all of you what Bardet-Biedl syndrome is. We are at least 29 genes and counting, and it's this complex syndrome of obesity, polydactyly, retinal degeneration, kidney failure, developmental issues in some people. Different people have different manifestations of Bardet-Biedl syndrome. But the vision loss is the part that I am involved with and that really affects people's lives significantly. At the University of Iowa, we have a Bardet-Biedl syndrome type 10 mouse model. And for those of you who can't see, I have pictures of the mice here. And the Bardet-Biedl syndrome type 10 mouse is very, very tiny when it's first born. We have to give it special food and take care of it in special ways. But as it gets older, it gets obesity, as people with Bardet-Biedl syndrome do. And it also gets retinal degeneration, just like people with Bardet-Biedl syndrome do. And we can watch this or monitor this on OCT, which shows us the layers of the retina, and on ERG, which shows us the electrical waveforms of the retina. And with generous research funding from Fighting Blindness Canada, the Bardet-Biedl Syndrome Family Association, and Envision 2020, we made a vector that would deliver the Bardet-Biedl syndrome type 10 gene. And this I'm showing a video of me doing a subretinal injection in a mouse that we do under the operating microscope, the same microscope I used for children, not in the same room, however. And you can see in the picture here, for those of you who are viewing, that the green area of the retina is the area that's treated. So with subretinal gene therapy, we don't treat the whole retina. We are treating whatever we can deliver with an injection that's given under the retina. In the mouse, it's about half the retina, and in humans, it's less than that, but we aim to treat sort of in the middle of the retina. And we made this visually guided swim assay for the mice. In humans, there's the multiluminance mobility test that was used in the Luxturna trial, where people navigate through sort of an obstacle course and different light levels. Mice don't easily navigate through obstacle courses, but if you put them in water and there's a platform, they will go for the platform and get out. And you can see in a mouse with normal vision, here I'm showing a mouse swimming to the platform. So we standardized this test using mice that had normal vision, and then mice using mice that had no eyes at all, to see how long it would take them to find a platform. And it goes without saying that the mice that have trouble seeing, it takes them longer to find the platform, but they do find it eventually. Just like people who don't have good vision, they get techniques, they learn how to find the platform. But with a treated Bardet-Biedl syndrome mouse, they really can find the platform as quickly as a normally sighted mouse. So that we knew that the treatment was working. And this is a graph that shows that it was statistically significant. And the most significant thing that we found was, I'm showing electroretinogram tracings, and this is showing the electrical activity of the eye. And in a treated mouse eye with Bardet-Biedl syndrome, there's our two little spikes of electrical activity. And in an untreated eye next to it, there is a sort of a wiggly but flat line. There's no electrical activity measured. And so all of the mice from the earliest age with Bardet-Biedl syndrome have no recordable electrical activity from their cones. But once we treat them, they actually get to normal cone activity on the electroretinogram. It kind of decreases a bit over time, but they have a very good response to this. So we're very hopeful about this when it comes to humans. So it works in the Bardet-Biedl syndrome type 10 mouse. So how do we get it to people? Well, we had to make a new version of the vector that had the actual human gene in it, because to treat the mouse, we put the mouse gene in. It's very similar to the human gene, but it's not exact. And then we had to repeat the testing in the mouse to make sure it was still safe. And then we could either try to start a clinical trial from scratch through the FDA, or we could work with a company to try to get it to patients quicker. And what we chose was to work with a company. And the company is Mira GTX. And we got more funding from Envision 2020. And I do want to just say that the Bardet-Biedl Syndrome Family Association in the US gave us sort of emergency funds during COVID to keep these mice alive, because we had already injected them and they were kind of asking people to decrease the number of mice they had and stuff. So I just want you all to know that patient advocacy played a huge role in this research. But when we got to this collaboration with Mira GTX, we tried two different promoters. That this is what kind of regulates where the gene will get expressed. And one of them was just in the photoreceptors, the cells in the retina that die first in Bardet-Biedl syndrome type 10. And the other was a CAG vector promoter that makes the gene express in all the cells of the retina. And we actually found that that CAG promoter was toxic at high doses, whereas the RK promoter, which is just in the photoreceptors, was well tolerated at every dose. So that was safer, so we moved forward with that one. We tried multiple different doses, and we did this in 1-month-old mice that are maybe equivalent to 3 to 4-year-old humans as far as the retina goes. There's not a direct correlation, but that's kind of what we think. And we found that in these mice, even out to 5 months after treatment, which is pretty long in a mouse, that we could record that electrical activity, especially in the high dose group, but also in the low and medium dose group. And that was for the rods, the cells that see in peripheral vision and see in the dark. And then the cones also had a really robust response, especially to the highest dose group. And really excitingly, when we looked out 16 months after treatment, which is really the end of life for a mouse, we did a cone stain on the retina of these mice. And what I'm showing here is an image of, it looks kind of like an X, but that's the eye, the whole eye that we've kind of cut so that we can lay it flat. And the green areas there are cones. They're staining with a cone stain. And the one on the left has bright green all over the place. It has a lot of cones. The one on the right has no cones whatsoever. And the one on the left is from a Bardet-Biedl syndrome type 10 knockout mouse. And so is the one on the right. They're the two eyes of the same mouse, but the eye that got treated kept cone function or cones all the way to the end of life. And when we did the swim assay, we saw that they did keep cone function as well. So we have a lot of different markers that show that in the mice, this really, really works to improve and delay loss of vision. So what have we learned? Well, we can activate these dormant cones and delay retinal degeneration in very young mice. We also tried this. Brianna Schoenfeld was a student in our lab who did this with older mice. And the older mice didn't have as much cone function recovery, but they still had improvement in vision on that swim assay, and also they kept their rods much longer. So even in older mice, which would we hope correlate to older people, there's some rescue of the retina. And so in collaboration with Mira GTX, this GMP grade vector was made by Mira GTX. We also did a natural history study at the University of Iowa, and I thank all of the patients who participated in that because that helps us know what endpoints to use for the human clinical trials. So we really appreciate that participation, and we're going to publish that data very soon. And finally, the most important thing is that the first patient has been dosed with this vector, and we hope to have more news on that in the very near future. Thank you.
Now I want to hand it over to Dr. Phil Beales, who has similarly been doing all of this work to be ready to test, and now has received a license to begin a clinical trial in BBS1, and he's going to share that information with us. Dr. Beales?
Hi, Tim. Hi. Hello, everyone from London. I'm so pleased to be able to not only be here, but also to speak to so many people. I believe from Tim that this is probably the biggest gathering of BBS folks, the BBS community that there ever has been. So it's, first of all, an immense honor to be here, but it's also more of an honor for me to be able to share with you some of our latest information around our upcoming gene therapy trial for BBS1, as Tim has mentioned. Let me just put this into a presentation mode. Right, so I'm Phil Beales. I'm co-founder and CEO of Exovia Therapeutics, which is a very small startup gene therapy company, which we spun out from UCL in order to be able to develop specifically therapies for Bardet-Biedl syndrome. So for those who know me, I've been passionate about Bardet-Biedl syndrome. I've been looking after patients, caring for patients and their families for the last probably 30 years now. Been involved with research, everything from gene discovery through to what do these genes actually do. And I never really thought I might live to see the day when there could be not only one, but two therapies available for, or at least to be tested, should I say, for Bardet-Biedl syndrome. And as Tim says, we're developing, and we have been developing with the team, the first gene therapy for BBS1. And this trial is about to start. It's called the AXIS trial. And Exovia has developed this gene replacement therapy, which is intended to halt or prevent blindness in patients with BBS secondary to faults in the BBS1 gene. It's important to know that this won't work for anyone else with any other type of gene therapy, with any other type of gene mutation, sorry, because the gene therapies are very specific to each of those. And it's important to say also that there are no existing therapies for retinal degeneration, vision loss associated with BBS1. So what is it this clinical trial is aiming to test? Well, it's trying to determine whether or not by placing a healthy gene into the eye that it's safe and that it doesn't have any bad effects, okay? The second thing we're looking for is early signs that this treatment could help people maintain their vision by slowing down or stopping the vision loss. And so very briefly, just to remind you what gene therapy is, I'm sure a lot of you have come across this at some point, but very simply put, it gives patients a healthy version of a defective gene. So we place the gene inside a vector, which essentially is introduced into the cell that is a problem. In this case, it's the photoreceptors, the rod or the cone in the back of the eye. And the intention is to restore the cell function. And in this case, in the back of the eye, it's about restoring the possibility of a rod or a cone to transmit light and therefore images back into the brain. Now, as you know, in terms of the background, BBS is a progressive disease. Most children, if not all children, are born with good vision, but then this deteriorates. And so these photoreceptors, as I mentioned, in the retina, they do die. And most patients have completely lost most of their vision by their mid-teens. And very much as Dr. Drack has shown in mouse models, we have also shown that the data suggests by giving this gene therapy, we call it AXV101, but it's just BBS1. It's a human version of BBS1 that we give to these mice that also lose their vision. They're good models for BBS. And what we've been able to show is they can slow and halt retinal damage in these mice that would happen in the eye that is untreated compared to the treated eye. And this has really permitted or allowed us to develop this first-in-human full trial for Bardet-Biedl syndrome type 1. So what are the expected benefits? Well, as I mentioned already, delay and prevention in vision loss, but there is a possibility that we may see some potential vision improvement. That's not our expectation. I want to be, clear about that. But we have seen that in some other clinical trials for inherited retinal dystrophies. So we will be very interested to see whether that happens as well. So what about this gene therapy? So we have developed this healthy gene and placed it inside a vector, which is an adeno-associated virus, okay? Why are we using a virus? Because Mother Nature has invented the best entry vehicle, if you like, to deliver the payload. In this case, it's the gene, it's the BBS1 gene, into the cell, into the target cell that we're trying to get it to. And some of the key benefits of using AAVs, as they're called, are, one, they're naturally occurring and they don't cause disease in their own right. They provide long-term expression. In other words, the gene, when the gene is switched on, we expect it to stay switched on for a long time, many decades. They also have a relatively low immune response. I'll come on to that in just a minute, when injected into the back of the eye. And for not only the scientists and the doctors amongst us, but also the regulators and you as patients yourself, you'll be pleased to know that this type of gene doesn't get integrated into your DNA as such, which is an important factor when it comes to designing gene therapies. So how is the therapy given? It's given as a single dose. So literally a single bubble of the gene therapy, a minute amount, is delivered literally with a syringe through a micro needle into the back of the eye, between the photoreceptor layer and another layer of cells called the retinal pigment epithelium, or the RPE. And we want to deliver it as close to those cells that matter as possible, and in the region of the eye where there is the most fine vision that we have. And that's where all the concentration of cones and rods as well is found in the eye, around the macula and the fovea region of the eye. So as I say, this is a single one-time delivery, which we are hoping will last for life. A brief word about the risks. There are potential risks with any therapy and also with gene therapies. And these are divided into really two areas, right? There are immune reactions. There's a risk of the immune response to the capsule, the vector itself, the virus. In our case, it's called AAV9, or to the actual BBS1 protein, because some people may not have actually who have BBS may not have actually been exposed to a normal functioning copy of the BBS1 itself that will be produced by delivering this gene into the cell that matters. So there are risks of those immune responses, but we do have methods of treating those if they happen. And like with all surgery, there are surgical risks. We would hope there will be no infections. But there are risks of, and very likely to be inflammation at the time of delivery, but that should be very transient. And there's also a significant risk of future retinal detachment as well, because you're actually delivering this medication between two layers of cells. So you have a temporary retinal detachment, which will then seal up over the course of a few days. But then there is a future risk of that as well. So I just wanted to be clear that these things are not without risks. So what are we going to measure? Well, fundamentally, we're interested in knowing whether, one, this is safe, and two, it's tolerated not only by the eye, but the body in general. And so the way in which we understand whether this is safe and tolerable is by measuring a number of ophthalmic assessments that you, particularly those of you who in the BBS community have experience of going to see your ophthalmologist, you will have had the standard group of tests, suite of tests, such as OCTs, such as ERGs, such as your visual fields and your visual acuity, looking at the letter chart, for example. So we want to measure all of those things at different stages throughout the actual trial itself. Another thing we want to be able to do is to capture any changes there may be in your quality of life, not only in your physical daily functioning as well, how you feel emotionally, how you might interact socially, for example, or, you know, does this improve your work or school? So these are really important measures to capture. So what does the actual trial design itself look like? So this is what we call an early stage or phase 1/2 study. And it will look at 2 doses of the actual medication itself in 12 patients. And those 12 participants, each of those will join the study for 2 years. They will be assessed over a period of 2 years. There'll be about 19 visits, so it's not trivial. And they will have all of those measures we mentioned a little bit earlier on done at most of those particular visits. And not only following the 2-year period, we will follow up every single participant for a following 3 years as well. So 5 years in total, to be able to get a good idea of not only the safety, but whether or not we're seeing early signs of benefit as well. So what does it take to take part? Well, there are key eligibility criteria. You need to be between 4 and 17 years of age. And you also need to have 2 confirmed mutations in the BBS1 gene for the reasons I mentioned earlier on. You also need to have signs of retinal disease, but there also has to be a relatively good level of retained retinal function, because gene therapies are good at maintaining cellular integrity and function, but they will not restore already dead cells, unfortunately. What about the trial sites? Well, this first study will take place in the UK. It's taking place in 2 hospitals here in London, Great Ormond Street Children's Hospital and St Thomas's Hospital. And these will both be the sites for drug administration and those clinical assessments I've mentioned. The reason we've chosen these 2 centers is because already there is a high volume of BBS patients who come to national clinics, who have been coming for the last 16 years now. So we have a lot of information and very comprehensive registries and clinical databases about these patients. These centers also have a significant expertise in not only subretinal surgery, but also in delivering gene therapy trials. And what we're hoping is that going forward, there will be, I'll go back to this one very briefly, that should the efficacy data show us that this is a really beneficial situation, we hope to open a larger phase 3 study, hopefully around the world, to be honest, not just based in the UK. So where are we now? Well, we've received regulatory approval back in July for this full clinical trial from the MHRA. And this follows all of the requirements around the Declaration of Helsinki. We've also received Research Ethics Committee approval as well. And we also have put together an independent data monitoring committee, which will have oversight and review all the safety and efficacy data that come out from the trial itself. And those who do take part will obviously take part with full informed consent, and those participants are able to withdraw any time from this trial without consequence as well. Data protection is absolutely fundamental, and confidentiality is absolutely paramount as well. And we've already appointed a research organization that will run this trial, and the trial will be kicking off this fall. I can't give you the exact date yet, that's yet to be fixed, but it's coming up very, very soon. And recruitment will be via those 2 sites, and obviously for those patients who meet the eligibility criteria. So it leaves me really just to thank all of the people who have been involved, in particular working very closely with BBS UK, Tonya, Angela, all the team there as well, to help design this trial and get us over the line. I also want to pay huge thanks to A Race Against Blindness, and particularly to Steve and Christina Johnston, who have helped to fund this trial. It would not be here today if it was not for their continued unwavering support for moving forward in this direction, and to Alsa Ventures as well for funding Axovia Therapeutics. So for me, this has been an amazing journey, and it's such an exciting time to be able to share with you what is just the beginning, I hope, of another journey, which with time we'll obviously be able to share with you the advances going forward. So thank you very much for your attention.
Thank you so much, Phil. It is so incredibly exciting to be at this stage, all the progress that has been made. And you want to also reiterate what Phil said. A Race Against Blindness is an organization led by a BBS family that has been raising funds specifically to support clinical trials and has been instrumental to being able to get us to this point. I now want to turn it over to Tanja Heimers from BBS UK. We are wrapping up here. So excited so many people could be with us. And I'm going to be inviting the other BBS leaders from around the world to join us as we wrap up and talk about what's next.
Thanks, Tim. It's been really wonderful to see the wider BBS community coming together today. So Just wanted to say really collaboration between patient groups, patients, clinicians and researchers. It's not optional, it's essential if we are to improve diagnosis, care and treatment for those living with Bardet-Biedl syndrome and other rare conditions. BBS patients and families face enormous challenges, but when we come together like today, share knowledge and stand together, we create a powerful community that brings hope and drives change. And I think we've really shown that today. Every story shared, every registry joined, every survey completed helps us to move research forward. Patients are not just participants in research, they are partners shaping its direction. So together across borders and across communities, we really are stronger. And by working side by side, we can ensure a more positive future for everyone living with BBS around the world.
Thank you, Tanya. And it is the message that we want everybody to go away from here today. I'm going to ask Iris and Matisse and Matthias and Ben to turn on their cameras so that you can see them as well. What do we do next? Where do we go from here? Couple of things we want everybody to hear. One is join with your national BBS organization. That is the most important thing that you can do to help us advance the work. We have to know who is out there and be able to connect everybody together. If you are in a country that doesn't have a BBS organization, please reach out to the BBS Foundation. Part of our goal, our mission, is to help form more BBS organizations so that everybody has access to a patient-led BBS organization for our own community, for us to have control over that. Second, join a registry. If there's a registry in your country, make sure that you're in it. That is the most important part for us to be able to advance the research. Something we haven't touched on here today is, and many of you know, that the first treatment for BBS-related symptom, IMCIVREE, for hyperphagia, that came about solely because we had registries. Rhythm was focused on different diseases that didn't have a registry and then learned that BBS did. And so they shifted their focus toward the syndrome that had access to patients that had data. And this is going to continue to be important not only for retinal degeneration across all the different genes, but across all of the ways that BBS affects us, is to make sure that we have the patients, we have the data. And so joining a registry is critically important. Again, if there is not a registry in your country, CRIBS is available to everybody around the world, no matter where you are. I'll reiterate, you don't need to join CRIBS too. It doesn't hurt. There's no rule against it. But if you're in a registry, we are all collaborating together to bring that information together. So you don't need to join multiple registries. And then finally, I'll say all of us patient organizations need the support of the community. If you're able to donate to your national BBS organization, please do. Those resources get channeled into doing things like this, to allowing us to bring together the researchers and the clinicians from around the world to make sure that everybody affected by BBS has access to up-to-date, accurate information to do the best for their children. And I know that's why we're all here, is whether we have BBS, the broader community, we are a family, we want to do the best for all of us. And that is, what all of our patient organizations are focused on. So now I'm going to ask the rest of our panelists who have presented today, who are still on, Dr. van Haelst, Dr. Huranova, Dr. Valverde, Dr. Pomeroy, please turn on your cameras so that we can say thank you to the community and everybody can remember BBS is a global family. And no matter where you are, there are others around you who are part of that family and working every day to make the future brighter for all people for BBS. So thank you to everyone for being part of this historic day. Order a BBS Global Day t-shirt. I put that link in the chat not too long ago. Share it. Those can ship anywhere in the world, and all of the proceeds for that go to support BBS organizations. Watch your emails. There will be a recording and a translated transcript available for everyone who's attended. And we look forward to working together as BBS organizations, as researchers, as clinicians, towards this better future. I told myself I wasn't going to cry, and I'm pretty proud. I'm not crying. I made it through without crying. So thank you to all of that. And for there, we will close.